All right, ladies and gentlemen, lesson 3.5, good old-fashioned adding and subtracting of fractions. And so when we get done here, we need to be competent in addition and subtraction of fractions and the steps and rules that go along with it. Now, first of all, common denominators. We all know we have to have a common denominator in order to add or subtract fractions. And there are usually two ways to find them. I'm actually going to point out the second way first. This is the one that you have probably been brainwashed into doing all of the time, and that is to find the lowest common denominator, or the lowest common multiple, and that being the smallest number that both your denominators will go into. And that is a fine, dandy way of doing it, and it is preferred by most math teachers for the main reason that at the end you have to reduce, or you are likely to have to reduce your fractions the least. Okay? But, and here is the thing, one that drives me nuts as a teacher myself is I will have students who will spend all day trying to find the smallest number that both denominators go to, as opposed to just doing number one here and at least multiply the denominators together. It will be a common denominator. For example, okay, if I have 1/8 and I have 1/6, okay, here's the thing that some students will do, and this is why at times method number 2 is not the most preferent, or is not the best always, is because I will have some students that will spend all day going, well, what is 8? What do 8 and 6 go into? What do 8 and 6 go into? And they'll take forever to realize that yes, they both go into 24, and 24 is the LCM. The problem is they spend more time doing that as opposed to doing the problem and getting it done and going on with life. I know right now that 8 times 6 is 48. 48 will be a common denominator. Okay? So, as opposed to spending forever doing method number 2, if you can't think of a common denominator smaller than 48 in a relatively quick time, just use 48, and you have to reduce more in the end. Okay? Yes, if you can realize that they both go into 24, do it. But let's not get so stuck on doing number 2 that we can do number 1 and we can make it work and we can get on with life, as opposed to sitting there forever and doing number 2. Now the other thing I want to talk about here real quick is why do you need a common denominator in addition to subtraction of fractions? So again, you'll recognize this little chart. I've modified it slightly from a previous lesson. But the idea behind common denominators can be thought of as an area issue. This is just a model. There are numerous models to show that. But so if we are going to add, so here are my pizzas again. I have my pizza that is broken up into 4 equal segments. I have my pizza that is broken up into 8 equal segments. And we are going to add 3/4 here to this 1/8 here. The problem that you have is the fact that the wedge slices on this pizza over here, the 8ths, the size of that wedge is different than the size of the wedges over here. Okay, obviously the quarters are bigger than the 8ths. And so in order to actually add them together, I need my wedge sizes to be the same. So I have to divide my pizzas in a way that the sizes of the wedges are the same. Now in this particular case, I actually only have to modify this pizza over here by subdividing it a little further, because the nice part, and I did pick this on purpose because it's one that I can do pretty quickly, but if I were to cut these wedge slices into half again, or cut them all in half, I guess, depending on how you want to think of that, then I can realize that I have 1, 2, 3, 4, 5, 6 eighths now over here. I still have my 1/8 there, and the important part of this is these wedge slices are the same size as the wedge slices over here, and therefore I am putting together the same size pieces. And so I now have 7 1/8 size pieces when I put them together. So in essence, that's what we're doing when we're doing our common denominators, is we are taking our pizzas and we are breaking them up into the same size slices. Now in some cases, you may only have to manipulate one of your pizzas like I did here, but in other cases, we may be manipulating both pizzas so that each of the pizzas are broken or cut into the same size slices. So that's basically what you're doing with the common denominator ideas, coming up with the same size slices of pizza. Okay, so now, again, we have our ways of finding our common denominators. Again, do not get hung up on the way. Okay, I prefer method number 1 and reduce later if you have to. Yes, I would love for you to do method number 2, but don't spend forever doing it. Now, if you already have common denominators, don't worry about doing any of the common denominator work. Just we know that we will have tenths as our, so this is a pizza that was broken into 10 equal slices. This is a pizza that was broken into 10 slices. Person A ate 3 of them. Person B ate 1 of them. How many in total? Well, we have 4 of 10th size slices. And this will reduce though, and that's one thing that we do need to do, is when you get a fractional answer, please reduce your fractions. So 4 and 10 both divide by 2. So if I divide the numerator and denominator by the same value, I will have 2 over 5, so 2/5. Okay, so make that a habit, 2/5. Okay, and B, we already have common denominators, so we don't actually have to do anything there. The denominator will stay the same. 7 minus 4 is 3. So 3/9, however, 3/9 will reduce because they both divide by 3, leaving me 1 and 3. So we do want to reduce fractions if we can, or if it will. In this case, they both happen to do so. So, all right, again, my rules, which I'm not going to pull them out, you have them on another sheet of paper. All right, so we need a common denominator for 8 and 12. Now, again, if you don't realize that 8 and 12 both go into 24, you could do 8 times 12, okay, and I could multiply the numerator and denominator here by 12, and that would give me a fraction, okay, and I would multiply by 8 and by 8 here, and that would give me my other fraction, which was, let's see, 16. Carry 1 8, that would be 96. And so you would do these, this would be 40 over 96. This, again, 96 here. Oops, sorry, 96. 12 times 3 is 48. And I could add them together. 48 plus 40 is 88. 96, and then reduce. Okay. Again, you can do that. The problem with, and this is why people beat on going to method number 2, is you do actually make your life simpler by using an LCM, okay? Knowing that 8 and 12 both go into 24, all right, 24. 8 times 3 is 24, so the numerator gets multiplied by 3 as well, so there's 9. Times 2, 12 times 2 is 24, so 5 times 2 is 10. The sum of my numerators is 19. And my denominator is 24 because I keep it, because that's the size of my slices. And I have 19/24, which 19 is prime, does not go into 24 evenly, so there's no reductions here. And this is why people like method number 2. It reduces the amount of simplifications you have to do later. In this case, but if I had it over 96, we would have to go through some simplification steps. So, again, your choices here, you could go to 80 by multiplying both of these by 8 and both of those by 10. But in this particular case, I know that both of these go into 40. So I am going to go with 40. Yes, I prefer method 2 if you can do it relatively quickly. But if, don't spend all day on method number 2. That's the bigger point here. multiplying both of these by 4. 8 times 5 is 40, so the numerator gets multiplied by 5. There's 25. And so my denominator is 40, and I have to use my sign and simplification rules. Let me fix that. To do my numerator. So 4 minus 25, well, that's a positive minus a negative base, or minus a negative. So we're going to subtract the values. So 25 minus 4 is 21. Basically, this is going to be your negative here, so negative 21/40. So we have to bring some of those other rules into play. All right. In this case, times 8 is the smallest common denominator, the least LCM. I say smallest at times, which is not accurate to mathematical terms. This will be negative 16. It is the least common multiple. And multiplying 8 by 3 to get 24. So I have to multiply 7 by 3 to go 21. And again, well, my denominators will stay, but because my signs are different here, I will subtract their values. So I will go 21 minus 16 is 5. And 21 had the larger absolute value, so it will be a positive. Minus a negative is plus. Okay? Or you can do the add the opposite if you want to, whatever you're comfortable with. But we are going to add these two together. Now the nice part in this particular case, I know 4 goes into 8. So I am going to simply multiply these by 2 and have 6 over 8 and plus 5 over 8. And there we go, my computer is acting up a little bit. So this will be 8, not 16. I don't add the denominators together. That would be wrong. 6 plus 5 is 11. And if we needed a mixed number, 8 goes into 11 once, with 3 left over, so 3 eighths. And depending on what you are needing for a solution, those would be your two possible outcomes. Some people will tell you that you have to go here. I don't worry about having to go from improper fractions to mixed numbers, because as I said a few lessons ago, most of the time you use a mixed number, you change it back to an improper fraction anyway. So either one to me is fine, as long as they are reduced to lowest terms, which there are no factors that are going to divide both of them evenly, so I'm not overly worried about, unless the directions say to give it in a certain specific way. So, from January 1st to March 14th, Earth completes about 1/5 of its orbit, while Venus completes about 1/3 of its orbit. How much more of its orbit does Venus complete than Earth? Which to me sounds like, well, if we're going to do much more, more than is a subtraction thing. Okay, so 1/3 minus 1/5. So standard subtract your fractions type of a problem. And in this particular case, let me change colors here. Common denominator for 3 and 5 is 15. 3 times 5 is 15. And in this particular case, that does happen to be the LCM. So I don't have to worry about trying to find something smaller. So 3 times 5 gives me 15. So I will multiply the top by 5 as well. Same factor. 5 times 1 is 5. And 5 times 3 is 15 here. So 1 times 3 gives me 3. My denominator stays the same. 5 minus 3 is 2. So Venus completes 2/15 more of its orbit than Earth does from January 1st to March 14th. And actually, you are going to, I forgot my little ending number or slide. So that is the end of the section. Do not go on and do 3/6 yet. You'll do that in the next thing. Do your 3/5. Good luck.